So let me just step into one of each of those. Hopefully we have enough time here. The first example is software-defined car, and I just wanted to show you what it means for hardware to cross over into software and software to cross over into hardware. The video at the top is a computer algorithm. It's detecting pedestrians, it's detecting cars, and it's sharing that information so we can avoid a collision. Okay, that's easy. We do that every day. But if you look at the second image, if you take a close look, the first frame has a red traffic light turned on. The second frame has no lights on, and the third frame has a red traffic light turned on again. And the reason is the camera is picking up the frames, right? Whereas the LED is flickering at 50 hertz per second. So it's unnoticeable to us, but the camera is picking it up. Now that becomes a problem. If you're a software developer, that's a problem, right? You can cause a car accident. So the flickering can pose a significant challenge in perception. So what are you going to do about that? Well, the first thing you have to dumb down, this is a superhuman algorithm, right, in one sense, right? So you have to dumb down the image processing a little bit. And you may want to take the code and then isolate that in a certain part of the system so it's protected, right? So you don't interfere with other parts of the code. These types of decisions actually have started to happen. If you're a developer in the gaming environment, you know about NVIDIA's stack. You know really well how it works. But more and more software developers are needed in these industries. Otherwise, we're not going to go anywhere, literally. The second example I wanted to give is in healthcare. Another example where hardware and software are crossing over into each other and the implications for product development teams, but also companies who want to make money. The Apple Watch is what's called it's a medical device, and it informs on vital health signs, and it actually helps diagnose. Companies in this sector, they're not only life sciences companies, but also high-tech companies. They're releasing product candidates. They're not just releasing drugs anymore. And again, if you're a software developer, if you're a product maker, and you want to get into this space, you actually make a decision. What category of product am I going to make? Am I going to be a type 1, type 2, 3, or 4, or 5? These are all classified according to the intervention that happens in healthcare. What's the examples of these medical devices? Glucose monitors, pacemakers, right? These are the types of devices. They all need software. And one of the interesting ones that's where software developers are participating significantly in is digital therapies. The image on the left is an example of someone who may have lazy eye. It's a condition that affects only one eye, and it can't see as clearly because it's weak. But they designed a software game. I think Ubisoft designed this, right? So it's a software shop, and it was designed as what's called a dioptic display. So instead of having a patch, you walk around with a patch of it, it's exercising the weak eye and strengthening the weak. And that's an algorithm. Right? The problem with that is you can't have a glitch with that algorithm. You could really mess up the patient. And so software developers have to understand the sector-specific requirements. What is a robust life cycle to evaluate the performance of this algorithm? Right? You can't just release it in the wild like a TikTok app, right? It's just not going to work. And while there's clinical chemistry and bioinformatics involved, there's going to also be a software development life cycle. So a product launch, when hardware and software cross over into each other, is very, very different.